Assalamualaikum and hello class. Today we will learn how to solve questions related to the applications of differential equations. Let's start the class. For question 1, at 12 midnight, while the temperature inside a house is 23 degrees Celsius and the outside temperature is negative 7 degrees Celsius, its furnace breaks down. 2 hours later, the temperature inside the house has fallen to 10 degrees Celsius, assuming that the outside temperature remains at negative 7 degrees Celsius. So the first question is, write the initial value problem mathematically and in differential equation form that satisfy the temperature inside the house after 12 midnight.
By using Newton's law of cooling, it's given that dT over dt equals to E bracket T minus Tm. T is constant, T is initial temperature, and Tm is the temperature surrounding medium. So, we can get dt over dt equals to K bracket T minus Tm. Tm is equal to negative 7, so we can get that dt over dt equals to K bracket T plus 7.
For the next questions, solve the initial value problem in A that give the temperature inside the house at any time.
To solve this question, we need to integrate both sides of the general equation, and by doing that, we get ln t plus 7 equal to kt plus c, where c is the constant. To that, put in the base number exponent on both sides of the equation. Know that exponent and ln will cancel each other out and leaving us with t plus 7 equal to exponent to the power of kt plus c. We need to subtract 7 on both sides of the equation and apply the law of exponential. By doing that, we get t is equal to exponent to the power of kt times exponent to the power of c minus 7. Know that exponent to the power of some constant c is equal to the new c. So we have t is equal to c times exponent to the power of kt minus 7. From the question, we know that 23 degrees Celsius is the initial value of temperature when the time t is equal to 0. So it is denoted as t of 0 is equal to 23. To find the constant c, we need to substitute this initial value into the equation. After we substitute and calculate, we get c is equal to 30. So now, the new equation we have is t equal to 30 times exponent to the power of kt minus 7. The question also states that after 2 hours, the temperature inside the house has fallen to 10 degrees Celsius. So this initial value can be denoted as t of 2 is equal to 10. We know that when the time t is equal to 2, the temperature is 10. We need to substitute all of this information into the equation to find the value of k. After we substitute, we get 10 is equal to 30 times exponent to the power of 2k minus 7. We simplify this, we get 17 divided by 30 is equal to exponent to the power of 2k. We need to multiply both sides with ln to remove exponent. After doing that, we get ln 17 divided by 30 is equal to 2k. After that, we need to divide 2 on both sides of the equation, and we get 1 over 2 ln 17 divided by 30 is equal to k. We need to substitute this value of k into the equation. Therefore, the equation we have now is t of t is equal to 30 times exponent to the power of t over 2 ln times 17 divided by 30 minus 7.
Last question for question 1 is, Determine at what time when the temperature inside the house reaches 5 degrees Celsius.
To determine at what times when temperature is 5 degrees Celsius, we will use the initial value problem that we got in solution B. T equal 30 e power of t over 2 ln 17 over 30 minus 7. So, we just need to substitute the value of temperature 5, then we move minus 7 on the right hand side to the left hand side and get 12 equal 30 e power of t over 2 ln 17 over 30. Now, move 30 on right hand side to left hand side to make it 12 per 30. Then, we ln both sides. On the left hand side, it will become ln 12 per 30. And on the right hand side, if we ln e, we will apply the log rule and get t over 2 ln 17 per 30. Next, we will simplify and solve for small t. After we simplify and solve for the t, therefore, we will get the t equal 3.23 hours.
Question 2. A large tank contains 20,000 liters of pure water. Brine containing 5 kg of salt per liter is pumped into the tank at a rate of 20 liters per minute, and the well-mixed solution is pumped out at the same rate. Find the amount AT of salt in kilograms in the tank at time.
Let A of t be the amount of salt in the tank. We can write the differential equation as dA over dt equals to R in minus R out, where R in is the rate of inflow salt and R out is the rate of salt being released. From the question, we know that R in is 5 kg per liter times 20 liters per minute, which is 100 kg per minute. Similarly, R out is A of t divided by 1000. The unit should be kg per minute as well. Step 1. Substitute rate in and rate out into the equation. By using the differential equation, we obtain dA over dt equals to 100 minus A of t divided by 1000. Step 2. Arrange linear differential equation. After rearranging, our differential equation 1 should be dA over dt plus A of t divided by 1000 equals to 100. Step 3. Identify P of t and find the integrating factor of V of t. We have this formula. Integrating factor V of t equals to e to the power of integral of P of t with respect to time. Since P of t is 1 over 1000, hence we can write it as e to the power of integral of 1 over 1000 times dt. After integrating, it should be e to the power of t over 1000. Step 4. Multiplying the whole differential equation by V of t. So equation 2 should be e to the power of t over 1000 times dA over dt plus e to the power of t over 100 times A of t equals to 100 times e to the power of t over 1000. Step 5. Derive the product of V of t and A of t in equation 2. We can write our equation like this. Differentiate e to the power of t over 1000 times A of t with respect to time equals to 100 times e to the power of t divided by 1000. Step 6. Integrate both sides. Integral of time derivative of e to the power of t over 1000 times A of t equals to integral of 100 times e to the power of t over 1000 times dt. After integrating, we can get e to the power of t divided by 1000 times a of t equals to 100,000 times e to the power of t divided by 1000 plus a constant c. Finally, we can get the answer a of t equals to 100,000 plus c times e to the power of negative t over 1000.